Hello everybody, welcome to Bodha Academy. I am Kamalakar, lecturer in physics. In today's video class, I am going to discuss problems which are asked in TS Eamcet 2019. First, we'll start with a problem which was related to kinematics. Okay, so in this problem, a ball is dropped from top of a building, and at the same time, second ball is projected upwards with a speed 14 meters per second. Initial separation between two balls is 21 meters. We are supposed to find when both balls meet, what is the distance traveled by first ball. Okay. Now, let us draw the diagram for this problem. So, first ball is dropped, so its initial velocity is 0. Second ball is projected upwards with a speed 14 meters per second. Okay. Let both balls meet in time t seconds. So for first ball, I can write h is equals to half gt square. H is equals to half gt square. So for second ball, I will be using the relation S is equals to ut plus half at square. I will be using the relation S is equals to ut plus half at square. So in place of S, the distance traveled by second ball before collision is 21 meters minus h. So it is S I will replace with 21 minus h is equals to ut. And here body is projected up. So A is replaced with minus g. A is replaced with minus g into t square. So this I can write it as ut minus half gt square. So half gt square we got it as h. So minus half gt square I can write it as minus h. So 21 minus h is equals to ut minus h. So minus h can be cancelled on both sides. So you'll get t is equals to 21 by u. That's equals to 21 divided by u value in the problem is given as 14 meters per second by, so 21 by 14. So this on simplification, we'll get it as, with 7 table we can cancel off. So we'll get 3 by 2 seconds. So time taken for both balls to collide is 3 by 2 seconds. Okay. Now, in this time 3 by 2 seconds, distance traveled by first ball we are supposed to find. That is h is equals to half gt square. This relation we are having. So that's equals to half. G value is given as 10 and t value we got it as 3 by 2 whole square. So this on simplification we will get it as 45 by 4 meter. This on simplification will get 45 by 4 meter. Okay. So let us proceed for the second problem. In the second problem is based on friction. Here 3 blocks are connected with a string and are pulled up the smooth inclined plane. Frictionless inclined plane means smooth inclined plane with a force 104 Newton. We are supposed to find what is the acceleration of the block. Okay. So 3 blocks, mass of first block is 3 kg, mass of second block is 5 kg, mass of third block is given as 8 kg, pulled with a force 104 Newton. For sake of simplicity, this diagram I'll redraw it as body pulled up an inclined plane. So I am considering a body of mass m which is pulled up inclined plane with a force F. Angle of inclination is theta, which is equals to 30 degrees, which is equals to 30 degrees. So here this m I will consider as equal to sum of three masses, that is m I will take it as m1 plus m2 plus m3. I will take it as m1 plus m2 plus m3. Now our body on inclined plane means the force which is acting downward the inclined plane is nothing but mg sin theta. Mg sin theta. And body is pulled up the inclined plane, so motion is upwards. So I can write resultant force is equals to F minus mg sin theta. F minus mg sin theta. So resultant force, so m we had used capital M, so F minus mg sin theta. Resultant force I can write it as ma is equals to F minus mg sin theta. Mg sin theta. But m is nothing but equal to m1 plus m2 plus m3. So I can write m1 plus m2 plus m3 into a is equals to F minus m1 plus m2 plus m3 into g sin theta, into g sin theta. So substitute the values. So m1, m2, m1 is 3, m2 is 5, m3 is 8 into a is equals to F is given as 104 minus again m1 plus m2 plus m3. I can write it as 3 plus 5 plus 8 into g value is given as 10 and sine 30 degrees is equals to half. So this on simplification we'll get a is equals to 1.5 meter per second square. 1.5 meter per second square. Okay. So this is a simple problem. Only thing is, instead of three bodies, we'll consider as equivalent single body which is pulled up inclined plane. Pulled up an inclined plane. Okay. So next problem. So this problem is based on oscillations. It's based on oscillations. So here a loaded spring and simple pendulum are suspended to the top of a lift. Initially, it is given that both have same time period. So I can write it as initially time period of a simple pendulum is equals to time period of loaded spring. So time period of simple pendulum is 2 pi into under root L by G. And time period of loaded spring is 2 pi into under root M by K. M by K. Both are equal. So this is the case when lift is at rest. Lift is at rest. Okay. So we can cancel off 2 pi, 2 pi. Square root also we can cancel off. So we'll get L by G is equals to M by K. M by K. Call it as equation 1. Okay. Now in the problem, it is mentioned that lift starts moving down with an acceleration 5 meter per second square. Now we are supposed to find what is the ratio of time periods in this case. Time periods of loaded spring and time period of simple pendulum we are supposed to find, and what is the ratio we are supposed to find here. So when lift moves down, when lift moves down with an acceleration, I can write with an acceleration A. I can, for a loaded spring time period, I'll take it as T1 dash, which is equals to 2 pi into under root M by K. This formula is independent of G. So there is no change in time period of loaded spring. For a simple pendulum, I can write T2 dash is equals to 2 pi into under root L by, actually you are supposed to write G here, but now the lift is moving down with an acceleration. So here G must be replaced with G minus A. So ratio of T1 dash by T2 dash, this was the question asked. T1 dash by T2 dash equals to how much? So if you do simplification, 2 pi cancel. So you'll get root of m by k into G minus A divided by L. Okay. Now I can write T1 dash by T2 dash is equals to m by k. We got it as L by G, equation 1. So m by k I replace with L by G. L by G into G minus A divided by L whole root. So L can cancel in numerator as well as in denominator. That's equals to square root of G value is given as 10, A value is given as 5 by 10. So this on simplification, we'll get the answer as 1 by root 2. I think you are able to understand this problem. Okay, our next problem. So this problem is based on heat and thermodynamics. So here, a 210 watt heater is used to heat 100 grams of water. We are supposed to find what is the time taken to raise the temperature of water from 25 degrees centigrade to 100 degrees centigrade. Okay. Now, for solving this problem, in the power is given. So we'll start with power concept. Power is equals to work by time. In thermodynamics, we know that according to Joule's law, work is given as W is equals to JQ. So I can write JQ by time. W is equals to JQ, where J is Joule's mechanical equivalent of heat and Q is heat energy. That's equals to J into. Now we also know that Q is equals to ms delta T. So I can write ms delta T divided by T. So power is equals to, in SI system, J value is 1. J is equals to 1. Therefore, 1 into mass is given as 100 grams. So in SI system, I can write 100 into 10 power minus 3 kg. Specific heat of water is given as 4200 joule per kg per degree centigrade. Change in temperature. Initial temperature is 25 degrees centigrade. Final temperature is 100 degrees centigrade. So change in temperature 100 minus 25, that's equals to 75 degrees centigrade. Whole thing divided by time. Whole thing divided by time. In the problem, power is given as 210 watt. So I will substitute it in place of P. I will write it as 210 watt. Now we must simplify. Therefore, simplify and find the value of P. So on simplification, we will get the value of T as 150 seconds. T as 150 seconds. Hope you are able to understand problems clearly and able to revise the concepts related to kinematics, thermodynamics, oscillations. Okay. So today we'll stop here. In next class, we'll proceed with the other Eamcet problems. Thank you.